be about graphing systems, okay? So a system is a group of equations that has multiple variables in it, and we can solve multiple equations with multiple variables in the same problem. So we're going to start by doing that graphically with some linear equations, and then we're going to learn how to do it algebraically. We're going to learn how to do it with inequalities, and we'll just keep building, okay? Okay. So we're going to solve linear systems by graphing today. So the graphing part should be kind of review. This should feel very familiar. Okay, so what we need to remember for today is that a line is the set of all the points that satisfy an equation by making it true. There's that vocab word. To satisfy means make it true. So if it satisfies an equation, then it's a solution, right? So all the solutions make up the line. Cool? Mm-hmm. Okay. So for example 1, this is a review problem, but it's just to get our minds in the right spot. We have to determine whether each point is a solution to this equation that is graphed here. Yes. So you can see that we have a y-intercept of 4, a b of 4, and then we have a slope of -3 over 1. So from 4, we go down 3, right 1, down 3, right 1. Everybody see that? Yeah. Mm-hmm. Okay, perfect. So to test whether these are solutions, we can do that algebraically by plugging them in. Remember doing this?
Yes.
We want to know if 1 equals, because that's my y, right? I put in the 1 for the y, -3 times 1 plus 4. We want to know if this is true. Well, -3 times 1 is -3.
Right.
Plus 4 is 1. So this is true. So this is a solution. We can say yes. Okay, look at this next. Look at this. Do you see that 1, 1 is actually on the line? Is anyone shocked by that? No. We expect that any point on the line will make this equation true. So we can either do it algebraically by plugging it in, or we can just eyeball it on the graph and see if it's on the line. So is 4, careful, is 4 0 on there?
Yes. No, 0.
No. 0.
0, 4 is, but not 4 0. So this is a no. What about 2, -2?
Yes.
2, -2 is. Okay, any questions about that? Okay, that was our warm-up round. All right, now we're going to get serious. A system is, a system of equations is a set of equations with multiple unknowns. Okay, the solution to a system is the set of all the points that make all of the equations in the system true. So it's not enough just to make one of the equations in the system true. It's got to cover them all. It's got to satisfy them all. Now in Algebra 1, we're just going to do 2 equations with 2 variables. But as you go up higher and higher in higher math classes, they'll start adding more equations and more variables. Okay, so graphically, to find solutions, we're going to look for points that are on both lines. I put a blank here, and then I filled in the blank right next to it like a dingbat. So that was just supposed to be both, sorry. I just kind of, whoops. All right, so the points that are on both lines are the points where the lines intersect. That should kind of make sense. Think about the intersection of 2 streets. Isn't the intersection of 2 streets on both streets?
Mm-hmm.
Yeah. That's where we get the name intersection. All right. So we're looking for points that are on both lines that make both equations true. So what is this point on both lines? 3, 3, 1. That should be a comma. Sorry. Okay, so that one had one solution, 3, 1. What about B? Yeah, do you see that these lines have the same slope? Okay, so if they have the same slope, they're parallel and they never touch. Okay, so this has no solution. Okay, this is different from when we were solving quadratics and we would have no real solutions, because those could have imaginary solutions. This just doesn't have any solutions at all. Does that make sense? Okay. All right, what about this one? All, do you see that there's like, how many are there? More than 2.
Or there's
3.
All of them? What's another word for like infinite? Okay, this one has infinite solutions. Okay, so if the 2 lines are the same line, then they're going to be crossing everywhere. They're intersecting everywhere, and they have infinite solutions. Okay, so these are our options for a linear system of equations. They can either have one point in common, none, because the lines are parallel and never cross, or it's the same line and they're touching everywhere and they have infinite solutions. Everybody happy with that?
Yes.
Okay, let's do some graphing on the back. All right, we can solve a system by graphing our own graphs and finding the intersection. Okay, so look at this first little system. It's got 2 equations in it. So the trick is we're going to graph them both and see where they cross. Easy. When I look at any equation with an x and a y in it, I know that I'm going to have like a slanted line, right? So if I only have an x or a y, I'm going to have either a vertical or a horizontal line. The trick is to remember which one is which. So if we have an x equals equation, remember that was like our axis of symmetry for a parabola, right? It's vertical. Okay, a horizontal line is a y equals like the horizontal asymptote from an exponential. So this one's going to go horizontal across at -5.
And then it goes out.
Okay, so that's one down, one to go. My next one has a b of -3. So I'm going to start my graph at -3 on the y-axis. Can you tell what my m is in front of my x? 1. So my m is 1 over 1. That means I'm going to rise 1 and run 1 to the right. Rise 1, right 1. And I can get a whole bunch of new points that way. Okay, I didn't hit anything going that direction. So I can also go backwards and down, right? Okay, and you are correct. They are intersecting at -2, -5. Let me label this y equals x minus 3. And the solution was -2, -5. So that just had one solution, the point -2, -5. Easy peasy? Okay. It's time to level up a little bit. Level up, level up. Okay, so what's my b value for my first equation?
4.
It is 4. And then my slope is, what kind of 1/2? Negative. So I'm going to go down 1, right 2. Double check that your graph is going down as you read it from left to right, like a book. What's wrong with the next one?
everything.
What do you mean?
I think it's gonna be parallel.
Okay, do you see that it's in a weird standard form?
You have to throw over.
Yeah, X is on the same side. This is standard form. So I want to rearrange it so I can find my M and my B. So I'm going to subtract away the X's and get 2y equals a negative X because I subtracted it away plus 8. Now what? Divide by 2. Okay, so I had a negative 1 in front of my X, right? So now I have a negative 1/2 X plus 4.
Oh my goodness.
So my y-intercept, my b is 4, and then I go down 1, right 2. Oh, holy crap, what do you know?
Infinite solution.
It's infinite solutions. It's the same line. Now we couldn't tell just by looking at it because it was rearranged. Okay, so sometimes you might have to rearrange it to see that it's the same line. So this has infinite solutions. Can I list them all here? No, that would take forever, literally. You would never graduate. Oh my gosh. All right, let's look at another one.
So then you
Oh, question. Okay. It's time for a big brain question. What would I have to change about one of these graphs to make this go from infinite to no solutions?
Make it not a negative.
Would I have to change the slope? Or would I have to change the y-intercept? The y-intercept to make them parallel. So if this was, for example, not a 4, but a 2, then it would go like this. And it would be parallel and never touching. Everybody see what I'm saying?
Yeah.
Okay. Okay, but it's not. Here we go. Last one. All right, my b value for equation 1 is -2. My slope is positive 1/3. I'm going to rise 1, run 3. All the way across. We're about to find out. Okay, what's a little wonkadoo about the second equation? Yeah, x's are on the same side. It's in standard form again. So we'll subtract away the x's, and we get a -3y equals a -2x minus 9. Now we're going to divide by a -3 this time. So watch your signs. Anything that was positive is going to turn negative, and anything negative is going to turn positive when we divide by a negative. Okay, so that gives me y equals positive 2/3 x plus 3. Okay, so my y-intercept, my b is 3. I'm going to rise 2, run 3. Rise 2, run 3. And then I can go backwards down to back 3. Down to back 3. Uh-oh. Now, these don't cross on my graph. But are they parallel?
No.
Okay, so are they going to cross eventually?
Yes.
Yeah. But as I get farther and farther away, my graphing is going to be more and more of a guess, and it's not going to be very accurate. Can you think of another way that I could find where these two cross? Yeah, you can put it in the calculator and check the tables, okay? When they have the same y value and the same x, then they cross. So everybody put both of them in the calculator. They're both solved for y now. I'm going to do it too. Okay, so it's 1/3, 1 divided by 3, x minus 2. And then was it 2/3 x?
Yeah.
Plus 3? Thank you. Okay, so I'm looking for, you see that going in the positive direction, they're just getting farther and farther apart? Okay, so I'm going to go in the negative direction. Whoop, there it was. Does everybody see it's happening at -15, -7?
Mm-hmm.
Okay, perfect. So that's my solution. Okay, so if they're not parallel and they don't cross on the graph, it doesn't mean that there's no solution ever. It means you might have to find it a different way. Any questions?
No.
Okay.
One more time.
One more time.